Okay, yesterday we stopped here. We have a antiderivative integral 6 of x cubed minus 8. Then we did the partial fraction decomposition. So basically we decompose it to two different, first the factor denominator, x minus 2x squared plus 2x plus 4. First we factor denominator, then we decompose it in two different fractions. Then we find ABC. We got our partial fraction decomposition is like this. Okay, so the first one, I think it's pretty simple. You got the answer is ln x minus 2. Okay, and then the second one, I want anyone tell me how do you think we can do the second one?
Can you factor out the denominator and then probably cross out negative x plus 2 and negative x plus 2 to leave us with 1 over the final, like, 1 over the whatever is left?
Bad news is we cannot factor this one. Okay, so how do we know if we can factor one quadratic function, we will not be able to factor the quadratic function? You have a very simple way to check it. Determinant. Can you close the door, please? Yeah, the determinant. The delta equals b squared minus 4ac. We check b squared. B is 2 squared minus 4 times 1, 4ac, right? Which is 4 minus 16, which is negative 12. And this is less than 0, which means there is no real solution if I said about this equals 0. So if you factor, you can't factor it. If you factor is x minus, x plus, whatever, you are not going to have a real number here. You only have an imaginary number. Does it make sense, Taylor?
Yep.
Okay. So if you use the determinant to check it and it is negative, which means there's no real solution for this quadratic equation, so we cannot factor it. We can use what? Lacey, could you please hold the button while you're speaking? Yeah.
You can use bx plus b over.
Yeah, we can try to, well, this is x squared, this is 2x. We probably can do one thing. The derivative of x squared 2x is 2. For example, if I did this, negative 2x plus, let me see, wait. If I net u equals x squared plus 2x plus 4, and du will equals 2x plus 2 dx, right? And then we do not have a so this one is only have negative x, so dx equals 2x plus 1 dx. Okay, so here I can do something, do a little bit change, x squared plus 2x plus 4. Well, the thing is, if you have something just x squared plus 2x plus 4 and any number 5, 6, 7, if you just have this, it'll be much easier. You know why? Because I can change this one into x squared plus 2x plus 1, then plus 3 and over 5. Then you are going to have x plus 1 square plus square root of 3 square over 5. Then everyone knows this is a what? This is a tangent inverse thing. So you're going to get a 1 square root of 3 tangent inverse of x plus 1 over square root of 3. Okay? So if it's just a constant on the top, I have no problem with it. If it's just a constant on the top, on the numerator, we don't have any problem. We just did 2 square form. So x squared plus a squared, because the antiderivative of x squared plus a squared over 1 equals 1 over a tangent inverse of a over x over a, right? You know this one. Okay. So if it's just a constant on the top, It's pretty simple. We can do it quickly. X plus 1, you divide the 4 into 1 and 3. There's a complete square and the square root of 3 square. And then you use the arctangent inverse. But the problem is now we have another additional negative x on the top, right? Well, so that's why I do a little bit of work before I get rid of the x. We can possibly get rid of the x, but this is, we can tell that the dx is 2 times x plus 1. Well, I can do negative x minus 1, which is negative x plus 1, okay? You can do this, negative x plus 1. And then plus 3 and dx. I will ask a student, since I will write this out, I would like to ask you, why do you think I do this? Can anyone tell me why do I do this?
I think so that we can separate the fraction into
Okay, so this one here, the reason I do this, because now I'm going to separate the top. Why? Because if I separate top right now, negative x plus 1, x squared plus 2x plus 4 dx, and plus 3 over x squared plus 2x plus 4 dx, I have no problem of doing this two, this one and this one. I just did this one for you as an example of 5 the square root of 3. I have no problem finding this one because the top is just a constant. You can use arctangent. I don't have any problem solve this one because I can use U substitution here right now. Okay, I'll give you 2 minutes now to try to finish that. See if you can finish it from here. Oh, my bad. I think I made a mistake here. It's du instead of dx. This is du. Both of them du. Okay. You can use this one to solve this one. Do you have a question, Lacey?
I wanted to ask why the 2 and 3.
Can you see that again?
Like from 2 into x plus 1 dx. We have x plus 1 dx there, but I wanted to ask why the 2 is not like multiplied.
Me here? I factored 2 out.
Okay.
Okay, so are you done? Okay, so if you are not done, I can help you a little bit. So first one, just keep the ln x minus 2. You don't have to change that. For this one, if I do the u substitution, it's going to be u negative x plus 1. Well, you can change the dx. Actually, dx equals du over 2x plus 1, right? The d, you can change it. You can do this, do a little bit of work. X plus 1 dx equals du over 2. You can just change that negative, keep the negative, put the negative in front. Okay? And then x plus 1 dx. X plus 1 dx is du over 2. No problem, right? If you don't do that, you can just do x plus 1. Put the negative in front still. X plus 1 dx, solve this one, you got dx equals du over 2x plus 1. And then du over 2x plus 1, then x plus 1 canceled out. You still have the same thing, du over 2. And plus this one, we got 3 x plus 1 square plus 3. I think I did this one previously. Complete the first square, add the 3 here. So you can just do this as x squared plus 2x plus 1 plus 3. This is a completed square. So then we have ln x minus 2 minus half. You can take it out, 1/2, because this is coefficient. Just 1 over u du. Plus, you can take the 3 out. 1 x plus 1 square plus square root of 3 square. And dx. Okay, so right here, I would like to ask Cindy to help me. What is the antiderivative here? Matthew, could you please help me with this one?
So the first integral would that be natural log of like u, whatever that is, so that'd be x minus 2 minus
Minus 1 half ln.
yeah,
U is what?
x minus, wait, would be the x squared minus, like whatever u is, x squared plus 2x plus 4.
Mm-hmm. Yeah.
That's about where I'm at right now.
So this is x squared, this is a squared. I give you the formula. See if you can help me. Okay. The formula is x plus a squared, x squared plus a squared dx equals 1 over a tangent inverse of x over a. So after I give you the formula, can you help me with it? Can anyone help me after the formula is given?
1 over
3 times 1 over root of 3.
1 over 3 times the u times the tan inverse of x plus 1 over.
Very good. Thank you very much, Lacey. You're right. Okay. So the final answer is ln x minus 2 plus half of, you could, sorry, not plus, minus ln, you can put the square root here, because 1/2 you get the square root, plus 2x plus 4, plus square root of 3, tangent inverse of x plus 1 over square root of 3 plus c. Okay, that's it. That's the final answer. Okay. The problem here, actually, it seems like it's long. if I just give you an integral like this, it's very usual, it's very often I can give you an integral like this. You have to do some change here and do this. But it's long because we have something in the previous separation. But if it's just this one, it's still okay, I think. Okay, especially the ln part. Okay, so this is the problem we did not solve yesterday. We have not finished it. So let's continue with the homework. I checked all the homework. It seems like none of them is really hard one. Let me see. It's what is WebAssign? Okay. So right now we're at homework. Have a look at homework 3. We did, right? So now it's homework 4. Okay, we have 28 problem, I remember. Is there any particular problem you would like me to explain? So first one is okay, right? Just the U substitution. Second one, U substitution, okay. The first few questions, I think it pretty much is it's fine. It's a U substitution. Okay, so is there any particular problem you want me to explain? I'll go through and you can look at it. Okay. I can probably make it bigger. Number 5 is just a U substitution. U equals Z minus 3. Number 6, U substitution, U equals T cubed minus 9. Number 7, U substitution, U equals X squared plus 6X minus 9. It's 2X plus, that's 2X plus 6, right? Factor 2 out. Number 8, you multiply the top and the bottom both by e to power X. Right? Number 9, you need to complete a square form. Use a formula. Okay. Number 10, is there any problem you particularly would like me to explain? Nope. Okay. Number 9, you complete a square form. You got a squared minus u squared form. Number 10 is the same. Number 11 is okay. Number 12, I think it's okay. Number 13, tabular method. Number 14, tabular method. Number 15, u equals ln x. Number 16, tabular method. Just one step. Number 17, tabular method, x squared can go to 0, x squared 2x 1 0. Number 18, okay. So number 18 is probably one of the difficult one over the previous 18 problems. I would like you to try number 18 again. Okay. This is the one I did yesterday. Okay, give you a little bit of help. You do u as cosine 3x, dv as e to the power 4x. Okay, do it twice. So are you done, everyone? Okay. Let me think. Can any student help me? Maybe let me think. I have never caught Is there any student I have not caught yet previously? Matthew, Eric. Okay, I think probably Bella, could you please help me? Yes?
I don't know.
Okay, how about we work together? I want you to continue with me, okay? So now if I do u and dv, u is cosine 3x, du is negative 3 times sine 3x, and du again is negative sine cosine x. Okay, so can you finish here? Help me finish this. Tabular method. E to 4x over 4 minus 3 sine 3x, and then
That would be plus before that.
let me hear plus. Okay, very good. There's a plus right here because it's a plus minus and plus. Okay, you have this is plus. Perfect. Okay, and so continue. We did a 4 here in this one. 16, right? Because it's this two. Okay, so continue. Yeah. Minus 9 cosine 3x. Then e to 4x over 16. these two go together. I think that's why I want to ask you, because I remember 3 of you missed that class. So it's Tabular method, which is very powerful and very useful. Okay, so if it's uv minus du minus v du, and the last part, you can see my my symbol here goes back to here. It goes back. These two together, and you have an antiderivative continue dx. Okay. Then what we have is this part is totally great. We have one part is 1 is exactly the same thing like this. E to 4x cosine 3x is pretty much the same, but just different coefficient. Then we will have e to 4x cosine 3x dx equals 4 cosine 3x e to 4x plus 16 3 sine 3x e to 4x minus 9 over 16 e to 4x cosine 3x dx. Okay, so now what do I do here? Can anyone tell me?
Then you
If we
add
can,
9/16 from the integral of theta for cosine of dx the left side.
Yes, plus 9 out of 16, the whole integral here. Okay, plus the whole line integral here on the other side. You do the same thing here, 9 out of 16 over the whole integral e to 4x cosine 3x dx. So these two will cancel out. Then this one will give you 1 plus 9 over 16 give you 25 over 16. And the integral e to power 4x cosine 3x dx equals these two. You can combine like term, common denominator, the 16. This one, if I change the 4 into 16, I multiply the top and the bottom both by 4. So the 4, and both of them have e to 4x common factor, and the cosine 3x plus 3 sine 3x. Just combine these two. Okay. I can't do the 4 here probably. For this one, I still have the 4 here, because this one does not have a 4 common factor as 4. So just the e to power 4x, take it out. The first one I have multiplied by 4, you have 4 cosine 3x plus 3 sine 3x. E to 4x, you can factor it out as here, common factor. Then both have a 16, you can multiply both sides by 16. So the final answer is e to power 4x cosine 3x dx equals 25 e to 4x 4 cosine 3x plus 3 sine 3x plus c. Okay. I hope everyone question.
yeah.
I can't hear you.
If we're using,
I still can't hear you. Can you have to press the button constantly? Yes.
okay. I wanted to ask that if we're using the tubular method, when do we stop like the integration and the differentiation?
That's a very good question. When you use the tabular method, okay, if
Because
it's
from the uv minus integral of v and du, aren't we supposed to stop like at the second line? Since we have like the
Right.
integral v.
right, this is tabular method. Tabular method is kind of like a quick way of integral by parts, right? You know that uv minus v du. This is a very good question. When do we stop? And I think we have discussed this question before as well. If we stop whenever it's a trig function, for example, cosine 3x or sine 3x, okay, we stop and it back to itself. So cosine 3x, I do twice. We stop at a cosine 3x. Okay, so if if it's something like, for example, we can look at this problem. This one, if it's cosine 3x, we stop at it. If you take the derivative, u as cosine 3x, du again, it backs to itself. Then we can put the other one back to here, then we're done. We don't have an integral actually. We do have integral, but we can put it back to the left side. There's another case which is just polynomial function. For example, x cubed e to 3x dx. Okay. For example, if it's like this one is a polynomial function, it's x cubed. When do we stop? We stop at 0. We let u and dv. U is x cubed, dv is e to 3x. We take the derivative 3x squared, take the derivative 6x, we take the derivative 6, we take the derivative 0. So the last part is 0. And this one is e3x over 3, e3x over 9, e3x over 27, okay, e3x, e to power 3x, e to power 3x over 81. So basically we do the antiderivative on this side, the derivative on this side. So derivative and antiderivative on this one, okay. And then we cross multiply, cross multiply, cross multiply, cross multiply. And the last part, we do have a last part here, but it's just because it's 0, it disappears. Okay. So the final answer for this one is plus, minus, plus, minus, plus. And so the answer of this one is x cubed e to 3x over 3 minus 3 times 9 cancel out, so it's x squared e to 3x over 3 minus what? Wait, plus 6 and 27 cancel out, which is 2 over 9 e3x, and have an x. Okay, and then the minus 6 over 81, 2 cancel out, so it's 2 over 81 divided by 3, 27 e to 3x. And then we do have a plus 0 e to 3x 81 dx. This is the last one. If you do the u dv, it will equal uv minus v du, right? And you do again all of this uv. We do have a v du in the end eventually. But since this one is 0, then this one is nothing here, is gone. So the final answer is just this whole thing plus c. So just the whole x cubed, you write everything here, and just the whole thing plus c. You don't have anything here because it's 0, multiply 0, and then plus c. That's your final answer. Does it make sense, Lacey?
Yes, it does.
Yes. Whenever you have x cubed, you continue polynomial function, stop at 0. Whenever have you cosine 3x, because if you use this one as a u, you cannot get it, and you can't get it 0. You do sine, cosine is alternative function comes back and again. So you cannot stop at 0. A polynomial function, yes, the end you have a 0. Okay, that's just a 2 different case when you stop. I hope that helps. For the student who has missed this class, the Tabular method, I think you have to go back to read the book again. Well, I think I've uploaded the video. I'm not sure. That one, probably yes. Okay, go to watch the video or read the book. Because Tabular method, for sure, it's going to be on the test too. You have at least one problem for sure. Okay. So number 18 is kind of the problem I want to explain. Because the number 17 is just so simple. That's why I didn't explain number 17. X squared cosine 2x cosine x dx. The reason I don't want to explain this one is just do u x squared 2x 2 0. We're done with this. I have a 0. You see, is x squared, and dv is cosine x negative antiderivative cosine sine, and the sine is antiderivative is negative cosine, and is negative sine. Okay. Then plus minus, and it's pretty simple. X squared sine x plus 2x cosine x minus 2 sine x plus c. Just one step, we're done. That's why I don't explain number 17. That makes sense? Or number 16 is the same. X sine x, x squared cosine x is the same, just one step. X10 u, right? And or 14 is the same. X7, no, X14 is different. 14 you just have to use substitution. u equals x power 8. Okay. For all of this example, actually, I just do think that just a very simple problem I want you to practice. It's not real technical problems. Only number 18 requires a little bit technique, like okay, you can do u equals x power 8 and du equals 8 x power 7 dx, and then you have this is e to power u dx x dx. You can just take as a du over 8. And the answer is just the e to power u itself. So e to power x8 divided by 8 plus c. Like for example number 14. Those are just one-step problem. That's why I don't think we have to explain. But if you need to explain, we can do that. Number 15, number 16, we just did number 17, number 18. Okay, number 19. The meaning of number 19 is actually use the differential to match the antiderivative with the correct interval. It means if you take the derivative on y, okay, number 19, if you take the dy over dx, take the whole thing derivative, 3x plus, take the derivative of the 3x, okay, so you would match one of the function in the bottom, dy over dx. I know the final answer dy over dx is cosine x power 4. You take the derivative on y, your final answer is 8 cosine x power 4. Do you need me to explain this one? Anyone? Yes or no? If you don't know how to do that, I'll do that. If all of you know how to do that, I'll just skip it. Does anyone need me to explain? It's just derivative. Yes or no? Product rule derivative. Are you okay, everyone? Okay. So it requires a little bit of work, but I'll just do it quick. Okay, I think nobody says anything. I'll just do it real quick. Y equals 3x plus 2 sine x cosine x cubed plus 3 sine x cosine x. So y prime equals 3, derivative 3 is 3. And derivative sine, product rule, so is cosine x cubed plus, keep the first one, 2 over sine. The second one is 3 cosine square times derivative cosine is negative sine. Okay, this is the derivative of that. Okay, product rule. The next one we also do the product rule is 3 cosine x square plus the derivative of sine is 3 sine x times derivative of cosine is negative sine. Okay, so the prime equals 3 plus 3. This is 3 minus 3. I'll just do that. 3 plus 2 cosine x power 4 plus, this is 2 sine, 2 times 6 is 6, 2 times 3 is 6, 6 sine x squared cosine x squared, and I have a negative here. Okay, and plus 3 cosine x squared minus 3 sine x squared. Okay, so 3 minus 3 sine x squared, those two give you 3 cosine x squared, plus this is a 3 cosine x squared again, plus this 2 you have a cosine plus 2 cosine x power 4 minus 6 sine x squared cosine x squared. Okay, this will give you y prime equals 3 plus 3 is 6 cosine x squared minus 6 sine x squared cosine x squared plus 2 cosine x power 4. Okay, this will give you that. And then you factor the 6 cosine x squared out. 1 minus sine x squared plus 2 cosine x 4. So the final answer is y prime equals 6 cosine x squared times cosine x squared plus 2 cosine x 4. So the final answer is the derivative equals 8 cosine x power 4. Okay, I would think it should be okay, and you can You can go back and do it again. If you have question, you can watch the video again. It just take the derivative with the product rule. Okay, 8 cosine x power 4. Let's see. Number 20, u substitution. U equals cosine x. I think that would be good, right? U equals cosine x. And then this will give you number 20, cosine x power 4, and sine x you can take a derivative of cosine, but it's a negative, so put negative in the front. And this is u, so you got negative cosine x power 5 over 5 plus c. That's it. Okay. Number 21. Okay, so number 21 we do not have a cosine. What do you think I need to do this one? Anyone tell me?
Can we factor out a sine and write the d of cosine?
Yeah, we can do sine x and the sine x squared. I hope that's what it says, dx. This will give you sine x squared and d over cosine x minus. But they're different. What do I do here?
Use the
Reduce formula or trigonometry identity?
yeah.
1 minus cosine x d of cosine x. Okay, so that's what I would do. Since this is you can do u substitution again. So it's u, so it's minus u, so it's going to be minus cosine x plus cosine x over 3 plus c. Make sense, everyone? It should be easy, right? And the only thing you have to pay attention is, I don't think you have problem. You just separate this and then change the sign into 1 minus cosine, then you are fine. And the 22, use power reduced formula. Power reduced formula for number 22. Do you need help? Well, you're okay. Number 23. Like if I give you problems in the test, like all of this, 22, 23, 24, like those kind of questions, do you think you're okay? Test 2. Second test, I think it's the end of this month. Would you be fine? Like I give you all the problems. It would be like for sure. These problems are pretty like normal questions of trigonometry integrals. Okay, so you should expect a question like those. 22, just use power reduced formula. I'm not sure if I should do this. I can do it real quick, and I'm not sure if you understand it or not. Or just explain the problems you think is hard, and we can do it slowly, and you understand it, right? So 23, what do? You factor the secant 4 into secant square. Then you use 1 of the secant square as d of tangent. Okay, let me do 23 real quick. So you got tangent square 6x. You put the secant 4 into secant square and another secant square. Okay. So right here, what you have is, you have tangent 6x square, secant 6x square. This 2 you can use it as a d of tangent 6x over 6. But I can put a 1 over 6 in the front. Right? Because d of tangent 6x, d of tangent is secant. Well, now I have tangent 6x here. What you need to do, you make sure all of them is tangent 6x. You can use the u substitution. So secant is 1 plus tangent 6x squared, and d of tangent 6x. Well, this is u, this is u, this is u. So then the rest is pretty simple, right? 24. You just separate the secant square into 2 secant. Okay, separate the secant square into secant x over 20 times secant 20 of x over 20. Then secant times tangent is d of secant. Okay, number 24. Secant x 20. You separate square into secant x over 20. secant x over 20 times tangent x over 20 dx. This 3 will give you d of secant. So the answer is secant x over 20 of d of secant x over 20. But since this derivative of this is you have 1 over 20, so I have to multiply 20 here to cancel that 1 over 20. You got it, right? Okay. So then this is the u, this is the u, so it's just 20 secant x over 20 square divided by 2 plus c. Does it make sense, everyone? Yes? Yes or no?
Where does the 2 come from when you divide it by 2?
Oh, here? It's, if I do, first, do you understand the 20 here?
Yep.
Okay, so it's 20 u du. U equals secant x over 20. Yes?
Yep.
Then it's 20 u squared over 2 plus c, right?
Yep.
Okay, so that's how you have it. Okay, and you can just have this u, this du, this u du. You can match it up with the 20 u squared. So I just skip that u equals that part, because if you put them the same, you don't have to do the u again. Okay, and yeah, 25 you use the sine. 25 you use the sine alpha, sine beta. You use the formula of 2 sine, wait, is it 2? Half, yeah. Half of cosine, my bad. Sine, sine, cosine. Cosine alpha minus beta minus cosine alpha plus beta. You use this formula and put this fine, and this is the multiplication. Right now is 5x times 4x. Right now is multiplication. If you change that into a summation or difference, then you just have a cosine x, cosine 9x, cosine x. So we just separate them. Is just a simple trig integral. Number 26, you can use use 1 minus secant square. Okay, number 26 is pretty simple as well. So just use 1 minus secant x dx. Can anyone tell me why I do this? Can anyone
You
tell?
don't have a
Yeah,
function for antiderivative for tangent.
yeah. And now this is just the power of 4. This antiderivative of secant is tangent. So just tangent x power of 4 over 0. So just power of 4 minus 1. Pretty simple, right? And number 27, use power reduced formula. Or you can use the cosecant, it's okay as well. Okay, you can use the 1 plus sine squared is, it's not tangent, my bad. Use power reduced formula. Use power reduced formula. Sine x squared equals 1 minus cosine 2x plus 1. Okay. 28, it probably just asks you what do you substitute, right? So 27, you use power reduced formula, negative 2 pi, and the x squared is 1 minus cosine 2x and plus 1 dx. Then this one you only have negative 2 pi to positive 2 pi. 1 half plus 1 is 3 halves dx plus, and you can change the plus into minus because you have minus there. Minus half of cosine 2x 2 pi of 2 pi dx. The half you can take it in front is just a simple cosine 2x now. And 28, you just do x theta. Can anyone tell me what I do x theta is? What trig substitution do I use here? It's 49 plus x squared.
X equals 7.
7 tangent theta. Very good. 7 tangent theta. Okay. So I think that's the homework 4. If you know how to do all the homework problems without asking any help, or you can know how to do all of them, I would think you'll be fine with this trigonometry integrals. Okay. I'll see you next week. We'll probably do a little bit more partial integrals. Then we'll do improper integrals. Okay. Have a nice weekend.